Hello everyone, welcome to the Ape Survey channel. In this video, we will introduce how to use the tunnel section.
The tunnel section in the software is a collection that includes three types of sections: explication, structures, and centered lining. These sections are independent of each other and do not interface with one another. User can create sections by manually editing them or by importing CED fields in DXF4 format. Before editing the section, please make sure you are familiar with the positional relationship between the design elevation, the centerline of the road, and the tunnel centerline. When you need to create a new section, the first step is to name the section. The section name should be concise and clear. Make it easy to distinguish from other sections of the same type. Default tunnel centerline offset refers to the default offset of the tunnel centerline relative to the design line. If the tunnel centerline is to the left of the design line, enter a negative value. If it is to the right, enter a positive value. If no other centerline offset data is provided, or no manual selection is made, the system will apply this default offset value. After saving, you will enter the tunnel section editing interface where you can edit the specific data of the section. When adding the inner elements of the section, we employ the line element mask. The section contour is added by combining multiple line elements such as acres, line segments, and circles. The elevation difference refers to the difference relative to the designed elevation. A value that is higher than the designed elevation is positive, and a value that is lower than the designed elevation is negative. Offset refers to the deviation from the tunnel centerline, with negative values indicating a deviation to the left and the position values indicating a deviation to the right. Now let's take a detailed look at the creation method for the four types of line elements: circle, line segments, acres, and rectangles. We will introduce the input method and the operational steps for each type of line element one by one. Firstly, for creating a circular line element, you only need to define the position of the circle center and its radius. The system will then draw a circle based on these parameters. Next is the line segment line element. To create a line segment, you simply need to define the elevation difference and offset for both the beginning point and the ending point. When adding tunnel sections, the acre line element is a crucial component. Now, let's examine each method one by one and demonstrate their specific optional step. The first method is the begin and rotate. This method involves inputting the data based on the begin point and the end point of the acre, as well as the deflection angle of the acre. For example, let's consider an acre with a begin point and an end point. Suppose the begin point is on the left side of the skin, and the end point is on the right side. If the angle is positive, the acre will extend in a clockwise direction. If the angle is negative, the acre will extend in a counterclockwise direction. In the software, after inputting the begin point coordinates, end point coordinates, and the deflection angle, the anchor will be automatically drawn. Make sure to input the angle in the correct format. For example, 12 degrees 34 seconds 56.7 can be entered as 12.34567 degrees. The second method is begin and the radius. In the method, we define the begin point, end point, and the radius of the acre. For instance, given a begin point and an end point, we needed to specify the radius of the acre. The radius is the distance from the center of the acre to any point on the acre. It is important to note that the radius cannot be less than half the distance between the begin and the end points. Otherwise, the anchor cannot be geometrically constructed. In the software, after entering the begin point coordinates, end point coordinates, and the radius, the acre will be drawn based on these parameters. If the entered radius does not meet the requirements, the software will display an error message. The third method is begin center rotate. The method involves drawing an acre by defining the begin point of the acre, the center point, and the deflection angle. In this case, the begin is a point on the acre. The center point is the center of the acre, and the deflection angle defines the angular extent of the acre. A positive angle indicates a clockwise direction, while a negative angle indicates a counterclockwise direction. In the software, after inputting the coordinate of the begin point, the center point, and the deflection angle, the anchor will be drawn based on this data. If the entered center point position is incorrect, the anchor may not be drawn accurately. Finally, we have the rectangular line element. To create a rectangular line element, you need to define the position of the geometric center and the dimension of the rectangle. After saving, the system will automatically draw 4 line segments to form the rectangle and store them. When importing a CAD section drawing, make sure that the graphic has been properly processed with the following steps. Ensure that the CAD drawing coordinate system is set to World Coordinate System. If the coordinate system is not WCS but rather a user coordinate system, please execute the command UCS and select World. Move the intersection point of the section's design elevation with the terminal center line to the orange of the CAD coordinate system. Select all point lines and perform the explode operation. Select drawing as a DX format file and transfer it to your mobile device. In the software interface, click the input button in the upper right corner and select the newly saved DXF file for import. Finally, the operations for modifying and deleting line elements are also straightforward. To modify a line element, simply click on it. To delete a line element, swipe left on it. Thus, the editing of a tunnel cross-section is completed. Go back to the software's main interface, find the tunnel over break or end break function, and change the section calling method of manual. Enter a mirrored coordinate, click Calculate, and the software will call the corresponding section for calculation. I hope this explanation has helped you better understand how to use the tunnel section library. If you found this video helpful, please remember to like and subscribe. Thank you for watching, and we will see you next time.